So here you see a sequence, which is just a list of numbers in order. You also see a series, which is the sum of a sequence. So what does a sub 2 mean? The second term in the sequence a sub n. So the second term would be 5. And for sequences, sometimes we use a sub n or b sub n or f of n or lots of different things. But when we talk about series, we always use an s. So s sub 2, what does that mean? It means the sum of the first two terms in the sequence a sub n. So the series s sub 2 is the sum of just the first two. Okay? So s sub 2 is 8. What would s sub 3 be? 15, because we would add that 7 onto the end of it. Okay? So we worked on this yesterday. Turn to the last page on the worksheet from yesterday, from Friday. Yes, this is Friday's work. It's called arithmetic series. They look the same. One says geometric, one says arithmetic. Okay, so let's look at number 22. And you have to remember the formula for the sum of a sequence. And the formula is the summation of a sub, well, not a sub 1. We usually say something like I equals 1 to 8 of a sub n. So what that means is I'm going to plug 1 into the equation. Then I'm going to plug in 2 and 3 and 4 all the way up to 8. And when I'm done, I add them all together. Okay? Well, the formula is the summation, S of n, is equal to, you take the number of terms, so we take n, we multiply that by the first term, which is a sub 1, plus the last term, a sub n, and then we divide the whole thing by 2. Why did you put 3? I have no idea. So, for number 22, this is the equation for the sum of an arithmetic sequence, arithmetic series. So, if I look at number 22, I can plug 15 in for a sub n. I can plug a sub 1. I can plug in 79 for a sub n. And I do know that the sum is 423. What am I looking for? I want to know n, which is the number of terms. So if the first term is 15 and the last term is 79, and if I add all the terms together, I get 423, how many terms were there? Now, there's a much longer way to figure this out that we're not going to bother. We're just going to use the formula. So plug everything in. 423 equals n is unknown. We're going to times that by 15 plus 79, and then we divide all that by 2. So I'm going to add these together. 79 and 15 is 84. 94. 423 equals n times 94 over 2. What is 94 over 2? 47. So I have 423 equals 47 times n. Divide by 47. And what do you get? 9. So n equals 9. What does that mean? There are 9 numbers in that series. So we took a sequence of 9 numbers and we added them all together to get 423. Okay, those are the easy ones. Number 23 is a lot harder. So we talked briefly about 23, but I'm going to rework it now. So What do I know about this series? They give me 3 pieces of information. Let's figure out what they mean. What is this? That's the first term. So S sub n equals n times a sub 1 plus a sub n over 2. So I know a sub 1. Okay? What does d equal 2 tell me? That's the common difference. So what do I know about this sequence? It goes up by 2 every year or every whatever the time period is. Okay? So can I put that in this formula? No, I can't. There's no place for a d. Okay? What does S sub n tell me? The last term is 21, so I know this. And the problem is asking me to find how many terms there are, but I don't know the last term. And that's what makes it tough. Sadie? How come? Okay, so so if I write the equation, the explicit equation for this is y equals mx plus b. Do I know m? M is 2. That's the amount of dollars per year. So y equals 2. Do I know my b value? I don't, but I can figure it out. B is always the y-intercept. It's always year 0. Did they give me year 0? No, they gave me year 1. So can I go backwards and create a sub 0? Yeah, so if I go backwards, what do I get? -5 because I'm gaining $2 a year. So this is -5. What year am I looking for? I'm looking for n. Well, guess what? This is a sub n. By plugging in year n, I have created a sub n. The only thing is we don't really know what it is, but we don't care. We can plug this in for a sub n, and that's really tricky, but it's something that we do in mathematics all the time. We didn't know what it was, so we plugged the formula in its place. Yeah, this is still 23. So, I get this. S sub n equals, what is a sub 1? -3. So it's n times -3 plus 2n minus 5 over 2. Okay? Now my goal is to get my n's by themselves, so I'm going to multiply in by n. So I get -3n plus 2n squared minus 5n. Can I simplify that? What is -3n and -5n? So 2n squared minus 8n. Can I divide by 2? Are the 2 and the 8 both divisible by 2? Yes. So I get my S of n is 21. 21 equals n squared minus 4n. I'm going to stop there. How many of you understand what I just did? Well, that's pretty good. Let me review it really quickly. So 21 goes here. I plug in -3 and I plug in the formula, the explicit formula. Now I just multiply in by n, and I get -3n plus 2n squared minus 5n. I put these together to make -8n, and then I divide everything by 2. So 2n squared minus 8n over 2, that turns into a 1, and this turns into a 4. So now I have 21 equals n squared minus 4n. Well, what does that tell me? 2 answers. Whenever you have an n squared or an x squared, there are 2 answers. Now, chances are, one of the answers isn't going to make any sense. Because how many ways are there to create a series and end up with one number? There's only one way to do it. Well, maybe you could create a series that actually had two different numbers, but this one isn't going to be one of them. So, how do I solve an n squared equation? You factor it, or complete the square, or quadratic formula, or graph it. But in all cases, what do I need to do with this 21? I need to move it to the other side so that I get a 0 over here. We want to find the roots. So my quadratic is n squared minus 4n minus 21 equals 0. And then I don't care what method you use to solve it. You can factor it, complete the square, quadratic formula, or graph it. Factoring is by far the easiest in this case. Are there two numbers that multiply to be negative 21 and add to be negative 4? Negative 7, so n minus 7 and n plus 3 equals 0. So what are my roots? 7 and negative 3. This had two answers, right? Why does only one answer make sense? Right, you can't have negative 3 terms. There is no a sub negative 3 or s sub negative 3. So this happened before the story even started, so that's not an acceptable answer, and 7 is the correct answer. What happens if I got something like 1/2 comma 5? Are those both valid answers? You can't have half. You can't have a sub 1/2. It's a sub 1, a sub 2, a sub 3. You can't have half terms. They have to be whole number terms. Okay, so let's look at number 24. So we're going to use the same trick that we used before. So 228 equals, do I know n? No. Do I know a sub 1? 4 plus, do I know a sub n? Well, I don't know it, but I know that the function is y equals 7x, and then I need to find the y-intercept, and I know at year 1 there were $4, and I'm gaining $7 per year, so if I backtrack 1 year, how much was there? Negative 3. So this is 7x minus 3. What year do I want to know? I'm looking for n years. So I plug in n. So 7n minus 3 over 2. Now I'm going to make this a little bit easier on myself. What is 4 minus 3? 1. So really, this is just plus 1. And that'll save me a little bit of time. So, multiply through. I get 7n squared plus n over 2 equals 228. Can I divide by 2? No. So one way to do it is to do 7/2 n squared plus 1/2 n minus 228. Okay, that's kind of messy. The other way to do it is just put minus 228 and graph it. So go under your y equals, and you have to use parentheses. Whenever you have multiple terms being divided by one term, you must put parentheses around it. So 7x squared, oops, I forgot my parentheses, sorry. 7x squared plus x, parenthesis, divided by 2 minus 228. Now if I push graph, well, I know that that negative number certainly is wrong. And I would expect that other answer to be a whole number. But just for fun, let's test it. So second calc I'm going to go to 0. So it looks like 8. So I'll pick my left bound at 7, my right bound at 9, and my guess at 8. And it says, yes, the answer is 8. I don't even need to worry about the negative version because that doesn't make any sense. You can't have negative terms in a sequence. Okay? What happens if I work down and I get an equation like this? 6x squared plus 7x minus 15. Can I factor that? I mean, can I try to factor it? Do you remember the method? You times these together, and we would get 90, negative 90x squared. And then I look for factors of 90 that add to be 7. My recommendation is just graph it, or use a quadratic formula. You don't want to complete the square. Whenever you have a number, a coefficient in front of the x squared, you don't want to complete the square. It makes things really messy. So you can use a quadratic formula or just graph it. And if you graph it, and the graph looks like this. Hold on. We'll try again. So if you graph it and the graph looks like this, what's the answer going to be? 2. What about the 1/2? That doesn't make sense. So we throw out the 1/2. Okay? All right. Oh, it's on the other screen.